All right, guys, you're welcome to question 40, and we are still solving problems on differentiation, still on the challenge, guys. And in the previous video, which is question 39, we talked about, in fact, we introduced quotient rule to us. I showed you how to utilize chain rule, quotient rule, sorry. We solved a problem that requires us to differentiate the function using chain rule. And this particular one we're about to solve is still going to be by quotient rule. Please, guys, forgive me for that. This is quotient rule. Now, whenever we have a rational expression, when we have a fractional expression, just like what you can see here, this is a fractional, or we call it rational expression of y. We simply apply the quotient rule. And what the quotient rule is just simply a very simple concept. Let's say if y is expressed as u upon v, and if you must differentiate y with respect, of course, u and v are all functions of x. I explained this in the previous video. Just want to show you again, just to refresh your mind. So all you need to do to differentiate this function like this, the first thing, you hold your v and you differentiate your u with respect to x, and you minus, take note, it's a negative, not addition, not product rule. Then the next thing, you hold your u and you differentiate your v, and finally you have it all upon v squared. So your v, you put a square right upon 8. So that is simply how to differentiate using the quotient rule, right? So let us go right into this video, and you can see in this case this could be my u, and right here this could be my v. So if I want to differentiate y with respect to x, I just simply hold my v, which is x plus 3, and I'll differentiate my u. So differentiating x squared plus 5 is just going to be 2x. I hope you guys know that differentiating x squared is 2x, and differentiating 5 is 0 because they're constant. Then minus, I'll hold my v this time. Sorry, I'll hold my u this time, which is x squared plus 5, which is my u. Then I'll differentiate my v, which is x plus 3. So if I differentiate x plus 3, of course, that is going to be 1, because when you differentiate x, you get 1, and 3 is a constant, you get 0. Then all divided by what? X plus 3 all squared. That is just how to utilize the quotient rule. That is really straightforward. We are simply done, but not really done, okay? We have to now clean up all of these expressions. So let us clean them up. So from here, you can see that this guy can distribute, and that's just going to be what? 2x squared and 6x, right? Perfect. Then the next thing, you can see 1 multiply any stuff is still going to be that stuff. So the negative sign goes into this stuff. We have negative x squared and negative 5, right? All upon x squared plus 3 all squared. So guys, you don't need to expand this denominator. You don't need to expand this stuff. Just leave it the way it is. Most of the time in the options, you don't have it expanded. So just leave it as it is, okay? You only just need to simplify the numerator, but when there's need for you to expand the denominator, I don't even think there will be need for it. So you don't have to expand it. Just leave it the way it is. Now, cleaning up all this stuff, 2x squared minus x squared, that's going to be what? That's going to be x squared, right? And we have here to be plus 6x, and we have here to be minus 5, right? Plus 6x minus 5. So all upon x plus 3 all squared. This is our dy dx. But that is not all. Before you even close it at this very point, you look out. Can we even factor this expression? Is there a way we can factor? Is there a way we can multiply two stuffs and it gives us minus 5? If you add them, you get positive 6. Is there a way? Is there any factor like that? Let us see. Minus 5 times 1 is minus 5. But when we add it, we don't get plus 6. And minus. So I don't think there's any way. I don't think it can be factorized. I don't think it can be factorized, guys. I don't think. So I think this is the final answer to our question. So this is the final answer. We've come to the end of this particular video. So if you find value from this video, please let me know in the comment section. And do not forget to subscribe, share this video to other learners. And I want to see you in the next video challenge. Thank you very much for watching. Have a wonderful day and God bless you. Bye-bye.